All right, so number 3 here, we're 4.6 part 3, examples 3 and 4. So on number 3, it wants us to take cosine of the inverse tangent of 2/3. All right, well, this is more like that f of g of 4 I showed you at the beginning on one of them. Is what if we just work the inside here? So can we solve the inverse tangent of 2/3? Well, remember, we're looking for an angle here, okay? So if I let inverse tangent of 2/3 equal theta, then that just means that everything here in the parentheses is theta. So really, I'm after cosine of theta. And what do we know about cosine of theta? Well, in terms of x, y, and r, we know that's x over r. All right, so we're going to come back to that. Now let's go look at that inverse tangent of 2/3 equals theta. Well, remember, we can switch that and use the inverse. So that means that tangent of theta would equal 2/3. And what do we know about tangent in terms of x, y, and r? Well, tangent is y over x. So we know that x is going to be 3, y is going to be 2, and so all we need is r. If we could find r, then we could plug it in up here and solve for that. All right, now, how do we know that that 2 and 3 are not both negative? Remember, inverse tangent is in quadrants 1 and 4, so therefore, there's no trick on there where we wouldn't know if it's negative or not. So we know this has to be a quadrant 1 angle. All right, so how are we going to solve for r? Remember, x squared plus y squared equals r squared. So that means that 3 squared plus 2 squared would equal r squared. So 9 plus 4 is r squared. So r squared is 13. Take the square root. And r is equal to, technically it's plus or minus the square root of 13, but which r value are we going to use? The positive one. Why? Because r is always positive. Okay, so we know x is 3, y is 2, and r is the square root of 13. So let's go back up to the top here now. We're after cosine of that theta. And cosine is x over r. And we know that x is 3, and r is the square root of 13. And we just got to rationalize this and get that square root off the bottom. So we get 3 square roots of 13 over 13. So that wasn't quite as bad as it actually looked. So let's try another one. So example 4. On number 4, anyway. So it says, find sine of the inverse cosine of negative 1/4. So let's take this. So inverse cosine of negative 1/4. Remember, when we have an inverse, we're looking for an angle. So we're going to set that equal to theta. So that means everything inside there is theta. So I'm really going to end up looking for sine of theta. And I'm going to go ahead and set that up. Sine is y over r. And so we're just going to use now this inverse cosine piece here to find x, y, and r. All right, so if inverse cosine of negative 1/4 is equal to theta, remember, do the inverse. That means cosine of theta is equal to negative 1/4. And we know cosine in terms of x, y, and r is x over r. So who's going to get the negative? Well, r is always positive, which means x has to be negative 1. So we know x is negative 1. We don't know y. And we know r is 4. Now, inverse cosine, remember, is in quadrants 1 and 2. And in quadrants 1 and 2, y is going to be positive. All right? So, using our x squared plus y squared equals r squared. We have negative 1 squared, plus we don't know y squared. And it's equal to 4 squared. So we're going to work this out. So y squared is equal to 15. And so y is equal to positive or negative square root of 15. But we already said we're going to use the positive. And so now 15 only breaks down to 5 and 3, so we can't simplify the square root. So we know our y is a positive square root of 15. All right, and then back up to the top. Now that we know x, y, and r, we can finish this problem. We said we're looking for sine, which is y over r. And we know y is the square root of 15 over, we know r is 4, so there is our solution.